All right, so this support workshop was inspired by some questions and support issues that have come through recently regarding certificates. And so in this workshop, we want to look at what certificates are, why they're useful, some of the circumstances that they're useful in, specifically in relation to deployments, the components that make up certificates, and how that relates to the certificate store in Octopus. So the first thing I want to do is just inspect a common certificate from a website. It's actually just the Octopus website here. So I should point out, actually, this support workshop hosted instance, it has a guest login. So if you want to go in and have a look at some of these scripts and the results later, just hit that URL there and log in as guest. You should be able to view the results of these. So I have a runbook here, and this is going to call OpenSSL to inspect the certificates from octopus.com. And the results of this call will give us a lot of information and some insights into what certificates actually are and the components that go into them. Looks like it's just taking a little bit there. Can do, just run it locally, just in case. So I'll pull up. Oh, this is the command that would have run anyway. So I don't have those. Try. Okay, that's better. All right, so what we have here is an inspection of the certificate that protects octopus.com. And from here, we can see that there's a bunch of different aspects to certificates that are important to us. So the first one we want to look at here is this this certificate here, and this S stands for subject, and as we can see, the CN, or the common name, is the name of the host name of the website that this certificate identifies, and in this case, it's any subdomain of octopus.com. And I here is the issuer, and this is some other company that we've bought the certificate from, probably. And then we're down here, we have the actual certificate itself. And then one of the challenges, or one of the features of certificates, is that there's only a small number of providers who are actually trusted. So if I look at this website here, okay, here we go. This is the list of root certificates or certificate authorities that browsers like Firefox trust. I think each browser has their own particular list of certificates, although I think they're, for the most part, quite common and shared between them. But there's only, these are the people or the companies who can distribute certificates that your browser will actually trust. And if we went back to here, what we'd find actually is this issuer is not someone the browser trusts. So by default, this certificate, this top level certificate, which is identifying octopus.com, isn't trusted. And so one of the features of certificates is the idea of a certificate chain. And so if we look at here, this string here, and we scroll down, we'll see that that's the same as the subject of this next certificate. And so what this means is that this particular identity, I guess, is represented by this certificate. And this certificate has been signed by this issuer. But again, actually, this issuer is not something the browser trusts. We have to go one level deeper. And again, we see that pattern of the issuer becoming the subject, and them having being identified by yet another certificate that has been issued by a third party here. And this one here is actually one that we trust. So if we look at AAA certificate services, we can see that this is one that Firefox and most other browsers will trust. And so because we can establish a chain from a certificate that's been issued by someone we trust all the way up to a certificate that identifies the website we're looking at, our browser says that's fine. We now trust we trust this certificate because each of these certificates in between establishes that chain of trust all the way up to the top. So an easy way to think about this is perhaps, let's say this certificate here represents someone called Jim. And Jim says, hey, I'm Jim. And you know I'm Jim because Jane vouches for me. And this certificate here represents Jane. And Jane says, hey, I'm Jane. And you know I'm Jane because Alice vouches for me. And this is Alice. And we know Alice. We trust Alice. Alice is someone we know and someone whose word means something to us. And so because Alice trusts Jane and Jane trusts Jim, we could say that because we trust Alice, that we also trust all the way up the top here, Jim. And that's how these certificate chains kind of work. The other thing to point out is that these certificates embed a public key. And so for encryption, the way public and private keys work is that a public key is just kind of this special number that you can give out to someone. And any data that you encrypt with your private key, which is a kind of a matching half of this pair, but the private key is something you don't share. So anything you encrypt with your private key can then be decrypted with the public key. And the reverse is true. Anything encrypted with the public key can be decrypted with the private key. And so certificates, although public keys are kind of an aspect of certificates, you never really see them being, or they don't really exist outside of the certificates. They're never a separate file. They're not something you have to handle specifically. They just kind of live in the certificate as part of it, and is shared along with certificates as a kind of a single unit. Private keys, however, are separate. This call here didn't expose the private key. The private key is only saved on the server that's hosting octopus.com. And as a consumer of that website, I never get to see the private key. That's a separate entity that is distinct from these certificates and the certificate chains. Okay. So what we see here is a trusted certificate because it's the issuer and the certificate chain that leads up to that issuer comes from a trusted source. So we, just because of the nature of how certificates are set up, we do have a level of trust in this, and we assume that people have been through processes that mean that when I get a certificate that identifies octopus.com, I know there was some external process that went on to establish that identity. Sometimes that can be, I mean, you might have to verify that you own the domain name, for example, or yeah, sometimes you even have to send off things like your passport. Actually, I've seen that. So there is an external process outside of this, the certificate here that we trust. Someone has gone through to verify that the person who claimed to own this domain name is actually who they say they are, and then that trust is then reflected in these certificates. But there is the concept of self-signed certificates, and the reason why people use self-signed certificates is because this process here of getting a trusted certificate can be expensive, and it can be time-consuming. And if you just got developers who need to spin things up locally and run some tests, then they need to. Well, one of the ways they can get around it is create self-signed certificates and do their testing with that. I'm just going to log in here because I think I haven't set up the permissions properly. I'll try and fix those permissions so the guest guest account has access to these. So you can generate self-signed certificates again with OpenSSL, and we have a command here in one of these runbooks that shows you, and that's this command here. So OpenSSL, like you can Google all these to find out the exact details, but basically what we're saying here is that we want to create a self-signed certificate that identifies this imaginary website, and the end result of this will be the private key, which is this separate file, and the certificate. And the certificate is that the identity as well as the public key kind of merged into one file there. And if we look at the details of a self-signed certificate, which we'll do with this OpenSSL command here, we can see that they actually literally mean what they say. So if I pull up this runbook here that I've run earlier, we can see that in generating a self-signed certificate, we have something that we have a subject of a website, and the issuer is that the same identity. So in this example, or to use the example of people vouching for one another, this is Jim saying, "Hey, I'm Jim," and if you want to know how you can know that I'm Jim, well, just go and talk to Jim, and Jim will verify me. Which is really to say that there's no actual identity or no guarantee of identity in self-signed certificates. No one's been through any process to establish that the person who generated the certificate owns this website, and you can't look at the subject here and have any guarantee or sense that this certificate actually identifies the particular subject that it references. There's still use cases where self-signed certificates are good, though. You can imagine if you have an internal web service, for example, just internal to your own network, and it's exposed by an IP address, say 10.1.1.1. If you create a self-signed certificate, you still get the benefit of encrypted traffic. You just don't get the benefit of verifying the identity of the service that you're talking to. But in an internal network, that's okay, because you know that you're talking to a private IP address, you know that you control the network, and that IP address can actually take or perform the role of identity. If you're talking to 10.1.1.1 and you're not actually sure who you're talking to, you've got bigger problems, and certificates aren't going to solve them for you. But for the most part, you can trust that because you control the internal network and the IP addresses that are assigned, the fact that you're talking to a particular IP address is kind of a trust, or the IP address itself is the identity of the thing that you're talking to. And a self-signed certificate in that case is still useful. And actually, I'm not even sure. I've never seen a certificate that actually verifies an IP address in the wild. It may technically be possible. I've never seen it, so I'm not even sure that it's a thing. But just to call out that there are cases in production where you will have a use case potentially for self-signed certificates, and those things are still valid. So what are the features that we have coming up in Octopus 20.5 is the ability to quickly create self-signed certificates. So if we look in the library here, go to certificates, and this new option here, create self-signed. And so this is just a kind of a quick way of generating the same certificates that you normally had to create with OpenSSL through a command like this, through this command here. So it's really just a shorthand to execute this on the server. You can still there's more details that you can put into a self-signed certificate that aren't exposed here. We're only exposing this common name field. There's a whole bunch of other kind of components to an identity that you can put into a certificate, even a self-signed one. And if you do need that additional level of customization, you can still run a tool like OpenSSL, generate the files, and upload them here. So I'll just do example.com. And so what we can see from the details of this certificate, again, because it's self-signed, the subject and issuer are both the same. That's kind of the definition of a self-signed certificate. So if we go back here, though, if you did want to do it the old-fashioned way, you'd be left with these two keys here. So this is the private key, and this is the part of the certificate ecosystem that you never share with anyone. It's self-signed, so there's nothing particularly valuable here. So I'll just share it. But yeah, normally you would go out of your way to make sure no one ever gets their hands on this. And then there's the certificate part, and this is the part that you share. And so that's this here. And so these text formats here, this plain text, I think this is base 64 encoded plain text. This format is the PEM format, PEM. And that's just one of a whole bunch of different formats that have been defined over the years for handling certificates. I think there's probably half a dozen of these formats now, but the two that you'll really see in practice are this PEM format and the PFX format. And so the PEM format, as you can see here, is just plain text. You can copy and paste it and view it in a web browser or in a text editor. The PFX format is binary. It's something that your provider or a tool like OpenSSL will generate. It's not something you can edit or view just within a tool like a text editor. The PEM format here, there's no capacity to password protect this. It is just a text file. There's no other additional layer of security on top of it. PFX files can actually be password protected. That kind of gives them a degree of security above the PEM format. But otherwise, they're mostly interchangeable. And in fact, OpenSSL can convert between the formats pretty easily these days. So depending on which particular format is good for you, you either get that format from your provider. And as an example, I'll show you what I mean by provider. So if we look at this, so this is a website that we have generated an SSL certificate for. And let's have a look at this one. So we do Apache. Right, so this is an example where the certificate is being handed to me in the PEM format. And as we can see, this is the certificate. This one here is actually that certificate chain. It's that list of intermediate certificates that go from the root CA, the one that my browser trusts, all the way back up to the certificate that of the website that I'm using the certificate for. And this is the private key. If I was to go in and look at the IIS one, I won't do it because it actually exposes the password, but that would be giving me a PFX file to download. So as you can see, most of these providers give you those different choices. And the difference really is that the PEM files tend to be used in Linux and open source applications, and the PFX file tends to be used in Windows applications. PFX was originally developed by Microsoft, I think, but it's since become an open standard. But it's still more popular in Windows applications. So how do we then put these files or these individual artifacts into Octopus? So if I look here, I have the ability to upload a file, but actually I've got two files. So what's going on? do I upload this twice? Do I upload the certificate and then somehow add the private key? And this is perhaps one of the benefits of the PEM format is that you can just edit and combine things in a text editor, and then use that result to upload a file. So if I had a PFX, I'd select it here. It's a single file. It's a single file that contains all the parts of that certificate. So it has the certificate, the private key optionally, and it has the certificate chain. And it's just one single file, and you can upload it here. For PEM, all you need to do actually is just paste one after the other. And the parser knows that to look for these headers here and break down the resulting file into its components. So I'm just going to copy this combined file here. I'm going to paste it in. Let's call this my self-signed cert. Because I'm pasting in a PEM file, this password doesn't make any sense. There is no password. That's not a thing you can do with PEM files. And here's the result of my certificate. So if I look at this, go details again. Yep, you can see that it has the private key, and that was this half here, and it's self-signed because the subject and issuer are one and the same. We can do the same with those intermediate certificate chains. So I'm just going to, you'll just have to take my word for it, but these are those 3 certificates that were reported or that were part of the certificate chain for octopus.com. I've just copied and pasted them one after the other, which like we did with the private key. And that's something else I can also just upload. If we look at that, is this one? So if we look at the details, we can see now we have that top level certificate. This is not self-signed because the subject and issuer are different. I don't actually have access to this. This is what we downloaded publicly, so there was no private key component to this. And this is the certificate chain. So those are those 2 certificates that go from the thing that we trust, which was the thing that Firefox in my case trusts, which was this, all the way up to the thing I was trying to identify, which was octopus.com.
Does the order in the when you're pasting the keys in the text editor, does the order matter for the chain?
I think it might actually. Let me try. Oh, that's a good question. Maybe it's smart enough to match one after the other. Let's see. Well, I have a feeling it might actually be significant. Yeah, okay, it's kept the 2. Yeah, don't quote me on that though. I think if you would actually then use this in an actual application, you may run into issues. So Octopus might just think that respect the order that you uploaded it in, but whether another tool would also respect that, I'm not sure.
So you'd probably have to put the root certificate at the bottom then? Or...
Yeah, so
okay.
The way I've always seen it is this is the certificate of the thing you're trying to identify, and it just progressively works all the way down to the thing that you trust.
Cool, thanks.
Yeah, good thing to watch out for though. Maybe if someone reports an error, the order of those certificates may actually be important. So what are some examples of where we actually use certificates? there's a whole bunch of steps, usually related around deploying web apps that reference these certificates. So if we look at, just go deployment here. So a couple of canonical examples are IIS. If I go to my bindings here and change that to HTTPS, you get the option of protecting the website that you're deploying with a certificate managed by Octopus. So that's Windows. The equivalent for Linux is going to be something like Nginx. Which again kind of exposes this idea of bindings. And we select HTTPS, you get the option to select that certificate. So this is a case where you would need to select a certificate that has the private key. The web server, when you're deploying to a web server, you need that private key as a way of using the certificate to establish trust and participate in those encrypted communications. Examples of where you maybe use certificates without private keys are with Kubernetes. So if we look at an example config file, this is an example Kubernetes config file. This authority data here, this is a certificate with no private key that's used basically as a root CA. Like a custom root CA, and what it means is that when my tooling talks to this endpoint, and this is HTTPS, this server here is identified by a certificate that is ultimately something we can trust by this certificate authority here. This is base 64 encoded again. So if we look at do echo. I think it's just base 64 decode. Yeah, right. So you can see here, the text in that config file is base 64 encoded, and it's just a certificate. And we would use this in Octopus. Just create my certificate here, paste that text in. You would use that certificate in a target, which is here. So I would use that as this one here. That's an example of where you would upload certificates without private keys. This config file here actually also identifies the user through a certificate. And in this case, it does have a private key. So this is the base 64 version of the certificate that identifies a user. So if I go 64 code, it's not gonna work. There we go. So this certificate identifies a user, and then we have that. Then we have the private key part of that as well, which was this one here. Right, private key. And so if I wanted to identify myself to that Kubernetes cluster, I would need to paste both these, both that certificate and the private key as a new certificate. So call this KS user, and my text would be the certificate and then the private key. What's that one? So here we can see that if you recall, the CN for websites was the DNS name, but when it identifies a user, this CN, this common name, is a username. this O here is like a organization, I think. And that's just a group. The system masters is a group in Kubernetes. And we can see this is not self-signed because subject and issuer are different, and it does have the private key, which means I can use this as a way of proving my identity. So using certificates in steps that specifically have that certificate field is one way of using the data. But quite often there's going to be cases where you want to just get access to the certificate and the private key components individually. An example might be if you're setting up Nginx manually, for example, or another web server like Apache. Quite often when you're protecting the websites, they'll reference those two individual components of that certificate individually as individual files. And the way you can do that is if you just reference the certificate itself as a variable here, and then in your steps, you can use a bunch of variables that will get individual components of that certificate, kind of extract them out. And so here we can see that this is the variable that I referenced, and then this dot certificate PEM. This is an expanded property of the certificate, and in this case, it is that this kind of there'll be something like this here, and so the result of that variable expansion will spit out this certificate value, and likewise the certificate private key PEM will spit out that private key part, which was going to look like something like that. So all I've done here is actually just printed them to the console, but what you could do, depending on your use case, is use these variables and write them out to files, and then reference the files that you've just created. And so if we look at the output of this, so we can see that certificate bit was printed out, and this is printed out fine because the certificate half of it was always going to be public. This is always something you share. This was me attempting to print out the private key, but Octopus was smart enough to know that private keys are passwords, and don't print them to the logs. So this masked value here shows that the private key was actually extracted properly, and it was just masked by Octopus as I tried to print it out. So what are the takeaways for dealing with certificates and Octopus? And so I think the first one is to know that or understand the various components of certificates, so that you have the certificate itself, which also embeds the public key. You have the concept of a certificate chain, which is really just a list of certificates one after the other that works its way back to a trusted authority. And then you have the private key, which is a separate entity again, that's always kept a secret on the server and never shared out with end users. The other thing to know was the concept of self-signed certificates. These are something you can create anywhere on your own. They don't provide any guarantee of identity, but they can still be used for testing and establishing encrypted connections. And self-signed certificates do have value even in production on internal networks, where you can establish the identity in other means through something like an IP address. The two kinds of files that you work with then are the PFX, which is that binary file that's probably going to be provided for you, or this PEM format here, which is plain text. The binary file is self-contained. It contains all those individual components kind of bundled up and optionally protected with password, whereas the PEM format is plain text and something you can copy and paste into these combined documents here to include the certificate and the private key and the certificate chain. Self-signing in Octopus 2020.5 makes things nice and easy for anyone doing that testing. With the the limitation that you can only set that CN, that common name part of the self-signed certificate. If you do want more granular control over how that certificate is created, you can still use a tool like OpenSSL yourself to create whatever you want and then just upload it in the second step. And that's it. That's all I really wanted to run through. So do you have any questions or anything do you want to get in more detail?
Looks good. Not at the moment. I think that was pretty clear.
Okay. All right. Well, thanks for joining. I'll put the recording up when it's available. And
Yeah, thanks, Matt.
catch you next time.
Have a good one. Thanks.
Yeah.